Next, we will move to the app.jsx file to try an example of fetching data from an API. Before diving into React Query, let's take a quick look at how this task is typically handled without React Query. To save time, I paused the recording and implemented a solution to fetch data from the JSON placeholder API to display a list of posts. Here is a common approach using the useEffect hook to fetch data. In this traditional approach, typically you would write the fetch logic inside the useEffect hook. Maintain three separate states such as loading, error, and data to handle different scenarios manually. Repeat this boilerplate code including the try-catch in every component that needs to fetch data. While this approach technically works, it comes with significant drawbacks. Notice how much code is required just to fetch and display data for one component. Now imagine repeating this in every component where you fetch data. You are writing similar logic multiple times across different components, which increases the likelihood of mistakes or inconsistencies. As your application becomes more complex, managing state and synchronizing updates across multiple components becomes a nightmare and time consuming. You need to manually manage loading, error, and data states, which adds complexity and increases the chance of missing edge cases. Also, if you need caching, automatic refetching, or better error handling, you would have to write additional custom logic for each component. With React Query, all of these pain points are eliminated. It abstracts away the need for useEffect and manual state management, eliminating repetitive boilerplate code. React Query provides built-in handling for caching, refetching, error states, and loading states, all with just a few lines of code. This allows you to focus on building features while React Query takes care of the heavy lifting. Now let's see how React Query simplifies this process in action by fetching data from the JSON placeholder API. We will display a list of posts. I will define a fetch function to retrieve post and use the useQuery hook for efficient data fetching. I just cleared the app component, so let's start fresh from the scratch. I'm going to import useQuery from React Query. This hook will make it easy to fetch and manage our API data. Now I'm going to define a fetch function. This will retrieve posts from the JSON placeholder API and prepare them for React Query to manage. The useQuery hook expects two arguments. I'm going to pass post as the first argument, which serves as a unique key for caching and invalidation, ensuring React Query knows exactly which data to handle. And by passing the fetch post function as the second argument, we tell React Query how to fetch the required data. Next, I will use React Query's useQuery hook to destructure its built-in states such as isLoading, data, and error. These states simplify managing server-side data effectively. If the isLoading state is true, we will display a loading label. And if there is an error, we will show the exact error message returned from useQuery. This simplifies connecting our fetch function to React Query and allows us to handle caching, refetching, and server state management effortlessly. Now, some of you might be wondering what exactly is meant by caching, refetching, or server state management. Let me explain briefly. Caching means storing data locally so that the repeated requests for the same data are avoided, which improves performance. Refetching ensures the data stays updated whenever needed, such as when the server-side data changes. Server state management refers to handling data fetched from an API and ensuring it stays in sync with the UI. This makes React Query a game changer for reducing boilerplate and ensuring consistent data handling. Now I am mapping over the data array to render a list of post titles. Using optional chaining ensures we avoid errors if data is undefined or null, a common edge case when working with asynchronous data. If the isLoading state is true, we will display a loading label. And if there is an error, we will show the exact error message returned from useQuery. While libraries like Axios or GraphQL request automatically throw errors for unsuccessful HTTP calls, the native fetch API does not. This means that if the HTTP response indicates an error, it won't throw an exception by default. To ensure proper error handling in React Query, we need to explicitly throw an error for unsuccessful responses. Here is how you can update your fetch post function to handle errors correctly when using fetch. In this code, we check if the response.ok property is false, which indicates an unsuccessful HTTP call. If it's not OK, we explicitly throw a new error with a descriptive message. This ensures that React Query can handle the error properly, showing the error state to the user. Before we wrap up this video, I wanted to quickly address a recent update in React Query. If you are using an older version of React Query, the syntax demonstrated earlier in this tutorial works perfectly fine. However, with React Query version 5, the useQuery hook now expects an object structure instead of separate arguments. The query key uniquely identifies the query for caching and invalidation, and query function specifies the function to fetch the data. This change makes the API more consistent and flexible moving forward. If you followed along with the older syntax, don't worry, the functionality remains exactly the same. Just make sure to update your code to match the latest version. For more details, check out the React Query documentation linked in the description. Since we are using the latest version, I am going to update the syntax here to align with this change. We have often mentioned that the post key we use in useQuery acts as a unique identifier for caching and invalidation. But what does that actually mean? Caching refers to React Query storing fetched data locally to prevent redundant API calls when the same data is needed again. Invalidation ensures that when the underlying data changes, React Query fetches the latest data automatically, keeping the UI in sync with the server. Don't worry if these concepts feel a bit abstract right now. We will dive deeper into caching, invalidation, and server state management in upcoming videos with real-world examples to make these ideas clearer. Do you remember the code we displayed in the beginning of this video? Having separate states for loading, error, and data, as well as a try-catch block. Notice how repetitive it is. As you can compare, our codebase is much cleaner now. The data, is loading, and error states are all managed by useQuery seamlessly without needing extra boilerplate. Here is a quick breakdown. We define a fetch function fetch post that calls the JSON placeholder API. We use React Query's useQuery hook with a unique key post for caching and invalidation. This ensures React Query knows when to cache, update, or refetch the data efficiently. React Query handles the loading, error, and success states, streamlining our code. Compared to useEffect and manual state management, this approach eliminates boilerplate code, keeping your implementation clean and easy to maintain. Recognizing these challenges sets the stage for why React Query is a game changer. In the next video, we will focus on demonstrating a working example, recap key concepts, and explore advanced features to show how React Query simplifies and optimizes state management.